Imagine you open up your math book and see a problem with numbers, fractions, variables, and it looks like a total mess. You think, multi-step equations? No way, I'm never getting this. But here's the secret. Every complicated equation can be untangled with simple recipe. Today, I'll show you how to break down the chaos into 6 clear steps that work every time. Whether the equation has fractions, parentheses, or variables on both sides. I'll even share the most common traps to avoid so you don't get stuck where most people do. By the end of this video, you'll turn those so-called impossible problems into easy wins. Ready to make multi-step equations simple and maybe even fun? Let's get started. My name is Mahmoud Kiasari. Welcome to Special K. Hello everybody, hope you're doing well. My name is Mahmoud Kiasari and welcome to another module of Algebra 101. So today at this module, as you can see, we are trying to talk about the multi-step equation. At previous modules, we were talking about the equations, we were talking about how we can use different kind of rules in the algebra itself, about inequalities and etc. So at this point, we are going to combine a couple of those, the multi-step equations and also having fraction inside of them. So without further ado, let's just start it. So at the beginning of the point, we have to see that what are the objective of this module itself. The first one is about distribute and combine like terms that we had from the previous videos. We have to move the variables as we have for the previous module. We were talking about it, but today we are going to use it in more some kind of detailed matters, in some kind of more steps to see that how's it going. And after that, we are going to talk about the clear fractions with LCD. For some of you that don't know, the LCD step for the least common denominator. We had videos about that one, so you can check that out. And at the end, we are going to perform sanity checks and verifying the domain, because we are going to see that what are the numbers that actually are prohibited and if our answer is going to be right or not. So let's just get started. Let's just have some kind of warm-up refresher. The first thing that you have to know is about the PEMDAS itself. What was PEMDAS? Again, like the previous videos that you have, the PEMDAS is abbreviation, parentheses, exponents, multiplication, division, abstract, and subtract. Why we do have that? Because it would happen sometimes that in your questions, for example, at exam, when you just look at one of those funny videos or some kind of try to check how smart you are in the YouTube itself, you have different kind of symbols and some kind of operations side by side by each other, and you have to know from what place you start, because if you just miss one of those steps or you just kind of have miscalculation related to the order of operation, you're definitely going to have the wrong answer. For instance, at this point we can see I do have 2 times 3x plus 1, and the question is that how I can simplify this. So the very first thing that I have to do is about the P or the parentheses itself. It means that right now I have to look what's going on inside the parentheses. I do have 3x plus 1. As you guys know about the like terms and unlike terms, 3x and 1 cannot be combined together. Why? Because one of them has x, another one has just a number itself. So 3x plus 1, we can say that it cannot be combined. So at this point, we are going to leave it as the way it is. Another thing that we know about the rules of distributive rule that we are going to talk about it in detail, we have that one, a times b plus c is equals ab plus ac. This is something that we know. So at this point, if I want to simplify that, or if I want to get rid of parentheses, I have to multiply 2 by 3x and I have to multiply 2 by 1. So at the end, I do have 6x plus 2. Since again x and 1 are completely separate terms and they are not like each other, we cannot combine them. The next thing that we have to know again about the like terms and unlike terms. So at this point, as you can see, I do have 4x minus x plus 2, and the question asks how I can simplify it. 4x and x are considered as like terms. Why? Because as you can see, both of them has the same variable. What was variable? Variable means as some kind of a number that we don't know anything about it right now, but we are going to find it in the future. So since we don't know it, we are going to put it as x, y, z, whatever you have in your mind as alphabets. So 4x subtracted by x plus 2, how I can simplify it? Obviously 4x and x are going to be some kind of like terms. Why? Because they do have different coefficient, but they do have the same variable with the same power. Remember, this is very important. So 4x subtracted by x is equals to be 3x. What about 2? As I just told you, 2 is not like the x itself. So I'm going to leave it as the way it is. Another term that we have was about the least common denominator. What is the least common denominator? If you remember on the fraction side, and you also can find it in the channel itself, when we were trying to add two fractions while their denominator were not the same, we had a problem. So at this point, we had two ways. Either we can use the common denominator in order to make their denominator the same, and after that add all of the fractions, add all of the denominators based on the thing that we have to convert it to, or we can find a number that we call it as a least common denominator. The least common denominator is another form of common denominator, but it's the smallest number that all denominators can divide into evenly. For instance, at this point, we do have 1 over 3 and 1 over 4. The least common denominator would be 3 times 4, and it is 12. It means that 1 over 3 plus 1 over 4 is equals something over 12 plus something over 12. I have to convert this one to this and this one to this. So the denominator is going to follow up the denominator. So at this point, 3 is going to multiply by 4 in order to become 12, and after that, 1 is going to have the same situation. 1 times 4 is going to be 4. 4 at this point should be multiplied by 3 in order to be 12, and also 1 has to face the same situation. So we do have this at this point is 7 over 12. So for this kind of question, right now everything is simple. Well, what will happen if our numbers are going to get bigger? If you do have some kind of challenging condition, we will talk about it, but just in case, I had a complete and separate video in my channel so you can look at it in order to completely understand what's going on. So that was about the warm-up thing, and let's just move to the recipe we were talking about. As I just told you, we do have 6 steps for any messy equations in order to solve that one. The very first thing is about distribute. As I just told you, if we do have a fraction like this, we can actually use the distribute rule and AB plus AC, just like the way that we did over here. So whenever you see a parentheses, try to get rid of that, because it's going to give you some problem at the very beginning of the point if you are trying to simplify everything. So get rid of parentheses. The second one is to combine the like terms. I just talked about it. When we do have a like terms, the very logical way is that try to simplify everything by combining the like terms. For instance, at this point, 2 minus 6 is going to be negative 4. 3x is going to be there by itself, so you have 3x minus 4. The next step would be about the move terms. As you just remember, sometimes the equations are like this. So what am I going to do in an equation? Again, try to remember at the end of each equation, you are trying to make our variable isolated, and after that put everything that is not related to that on another side. So it means that there are some point or maybe two-step equations that you do have x in one side of the variable, one side of my equation that we call it as the left expression, and we do have another one over the right expression itself. So somehow we have to get rid of it, right? So it would be better to move one variable from one side to another side. So on that point, as this question, as you can see, I do have 7x subtracted by 5 is equals to what? Is equals to 3x plus 19. So the very logical way is that I have to move the 3x to another side. As you remember from the previous module, in order to get rid of that, we have to use what? We have to use, since it is positive, we have to use the inverse operation. So at this point, what do I have? I do have 4x minus 5 is equals to 19. So at another point, or the next step, I have to move this number to another side. Inverse operation. So I do have 4x is equals to 24 itself, and right now I can find my x. Another thing that we have to know is multiply by LCD. Whenever you see a fraction, because fraction and parentheses are two things that are going to overcomplicate your equation. So in order to get rid of that, for the parentheses, we have to use the PEMDAS itself, the order of operation. It means that whatever number beside the parentheses have to be multiplied by whatever number that you have inside the parentheses itself by respect to the sign. And after that, for the LCD itself, we have to get rid of the fractions. The very best way in order to do that is what? Is multiply everything by LCD. For instance, look at this question. You have x over 4 plus 3 over 4 is equals to 7. The way that we can get rid of both fractions at the same time is that finding the LCD between 4 and 2. We know that the LCD of 4 and 2 would be 4. It means that 4 is going to be divided by 4 and also 2 evenly as well. So multiply everything by 4. Another thing that I mentioned in the previous video was that whatever you're doing with one side of equation, you have to do the same thing with another side of equation, because again, we are not going to change anything. Whatever we are doing with this side of a scale, we have to do it with another side of a scale to make sure that everything is the same. We are not going to change the question itself, because if we are going to do that, I mean, just multiply something but one side of equation and don't do that on the other side, 99% of the time the answer is going to change, and that 1% of the time when we get the right answer, actually it was just by luck. So we are completely trying to avoid that. So at this point we are going to multiply both sides by 4. 4 by this part and also 4 by this side itself. Another thing that we have to remember, isolate the variable. As I just told you, equation or solving equation means that isolate the variable, which is x, y, z, whatever, and after that put everything on the other side. It's going to be about the coefficients and also about the constant itself. So what do I have? I do have my 4x is equals 24, right? So right now I do have 4x. The question actually is how I can find the x itself. So 4 multiplied by x, again, inverse operation. Inverse operation, my x is going to be 6. And at the end, which is a very, very important step that all the time I'm telling my students, is about the substitution and check. It means that wherever you find your x as 4, -2, I don't know, -1/2, whatever, you have to check it and put it into the question itself to make sure the left side of equation and right side of equation are going to be the same. So from now on, we consider the 6 steps as our main recipe, and after that, by solving equation and solving questions, we are trying to see that how we can actually use them, because not all the time you need all of them. You need at least a couple of them together, but we have to see how we can use them in the question itself. So let's start with the very first example, which would be about distribute and combine. So how we can do that? Again, for the distribute and combine, where we are talking about it based on the rule that A times B plus C is equals AB plus AC. Whatever number that you have beside the parentheses should be multiplied by whatever you have inside the parentheses. So at this point, I do have 3 times x minus 2, now subtracted by 4, and the question asks how I can simplify it. The very first way that I have to use is distribute, right? So I have to follow this. At the end, I do have 3x minus 6 subtracted by 4. If you remember from another step was about the combining the like terms, because as you can see over here, I do have 2 numbers and 1 variable. How I can simplify it? Easy, by having these numbers together, combine them. So I do have 3x minus 10. So that was a very, very basic equation that we have. Again, that cannot be considered as equation, because as you remember, equation means that one side of expression is going to be the same as another side of expression. Since we don't have the second side, we just call this one as expression or simplification of expression. So the next point would be about variable on both sides. Imagine I do have this kind of equation itself, and right now I would like to solve it. Again, as you can remember, I told you in order to solve an equation, you have to move all of the variables in one side and keep all of the numbers in another side. So at this point, I do have 7x on the left and I do have 3x on the right. How I can get rid of one of those? It would be better to move the smaller number to the side of bigger number in order to give positive all the time. Again, it doesn't matter if you move the 7x to another side or 3x to another side. At the end, you have to only be careful about your multiplication or division. Try to follow up all of the signing. I mean, negative by negative, negative by positive, and etc. So at this point, let's start the work with getting rid of the 3x on the right side and move everything on the left side. So it means that for the first step, I have to subtract 3x from both sides. We know that this is positive 3x, so I have to use the inverse operation for both sides. Again, I'm doing it for both sides because I'm not trying to change my balance. So 7x subtracted by 3x, I do have it as what? I do have it as the 4x itself. So 3x over here were gone because 3x was subtracted by 3x. So I do have 4x minus 5 is equals 19. So at this point, I do have this one, right? I do have this part. The next part is going to be what? Combining the like terms. Again, that was the first step. Somehow you can combine the two steps together because you don't have to overthink about the problem itself. Try to simplify everything. So I do have 4x minus 5 is equals 19. So isolate the variable. Isolate the variable means that I have to keep my variable in one side beside the coefficients, whatever it has, and move everything to another side. Since I do have negative 5, I have to use the inverse operation. Inverse operation. So 4x is equals to 19 plus 5, and 4x is equals to 24. Remember, we need the the x itself, not the 4x. So I have to divide x by 4. I have to, divide both sides by 4 in order to find x itself, and x is equals to 6. In order to make sure that our answer is right or not, we can put x as 6 over here to this side, and if both sides are the same, it means that our answer is right. Another thing is about the fractions and LCD. As I just told you, sometimes it is so simple. For example, you have 3 and 4, you can multiply them together, and the common denominator and least common denominator is the same. What would happen? Our number are a little big, and somehow we can find the least number rather than just the common denominator itself. Imagine at this point, I do have two numbers. I do have 4 and I do have 6 itself. If you look at my previous videos about the least common denominator, I showed you a way in order to do that. So the way is just like this, 2 steps. Try to write down your numbers as prime numbers. It means that the multiplication of prime numbers. For instance, 4 is going to be equals to what? Is going to be equal to 2 to the power of 2, and 6 equals to 2 times 3. Is that fine? So at this point, I do have these two numbers itself, right? In order to find your common denominator, that was the first step. And the second step is that find the common prime numbers with highest amount of power, consider that. And also this one is going to be this one. So, and after that, after you finish with the common numbers, consider the uncommon numbers and multiply all of them together. So at this point, I do have 12. It means that 12 can be divided by 4 and 6 evenly. So at this point, 12 is the least common denominator of 4 and 6. So for sure, I know that if I want to get rid of both of fractions at the same time, I have to multiply everything by 12 itself. So let's look at this question. I do have x over 3 plus y over 4 is equals to 5 itself. So this is one of those exceptional equations that we haven't talked about it before. This is one equation, two unknowns. So when you're talking about mathematics, whenever you have different kind of unknowns, you have to have the same number of equations in order to find both of them. For instance, when we do have x and y, we have to make sure we do have 2 equations in order to find both of them. Rather than that, the second number could be anything, the first number could be anything, so we can solve that. So at this point, this is just an example that how you can get rid of the LCD. So don't worry about it. You cannot solve it right now. Yes, if you just use some numbers in your head, maybe you can. But imagine that your equation is going to be way, way, way more challenging than the thing that right now we have. So try to just focus over finding the least common denominator and get rid of the fractions. So as you can see over here, I do have x over 3 plus y over 4. So as we know, 3 and 4, the least common denominator is 12. So I have to multiply 12 by this side and this side. 12 by 5 is just 60, easy. What about this one? Again, remember about the distribute rule. This guy multiplied by this one, this guy multiplied by this one. So I do have 12 times the x over 3. It would be 12x divided by 3, which is 4x. Why? Because 12 can be divided. We can divide 12 by 3 itself, so we do have 4x. Do the same thing with another one. We do have 12 multiplied by y over 4. So we do have 12y divided by 4. So it would be 3y. What do I have at the end? 4x plus 3y. And after that, I do have 60. Can I simplify it more? No, we can't. Another thing that we have to know is that sometimes your equation, again, is going to be messy. By how? By having the variable itself, instead of just being a denominator on the time, we do have it on the denominator. So at this point, everything is going to be challenging. You would panic and say that, oh my God, I remember that variable should be on the denominator, so that was easy. I have to get rid of fraction and blah, blah, blah. But what would happen if I do have that my variable on the denominator? So everything would be the same. Don't worry about it. Again, we have to get rid of the fraction, but instead of just multiply everything by the common denominator or the least common denominator, we have to multiply it by that term we do have on the denominator itself. We will talk about it. Well, one thing that you have to know is about the domain itself. What is the place that actually domain comes from? It comes from the fact that whenever you have something like this, for instance, whenever I do have a fraction is a over b, right? For instance, I would choose a number for my denominator 4 and I choose another number for my b. So 3, 2, 1, whatever. But the problem comes from the place that my b is equals to 0. So that is something we know as undefined, or some kind of positive infinite or negative infinite, which is something that we cannot talk about it because we don't know what would happen. So if I want to give you a very, very intuitive example, is that imagine the 0 resembles a very small number. Imagine that 4 divided by 0.000002. If you do that in your calculator, you will see a very, very, very big number, which you can call as positive infinite, which is not going to be our solution. We don't need that. We need whole numbers, we need fractions, we need numbers that actually we can touch, we can sense. So having this kind of numbers is going to be problematic for us. In order to solve that, we consider exception for our answers. It means that I have to find every number that I can for my variable, which at this point is b itself, or at some point x, y, and z, rather than the 0 itself. It means that 0 should be undefined. 0 should be completely ignored. So whenever we're talking about the fractions like this, it's actually 2, let me write it down, 2 divided by x minus 3 is equals to 5. Whatever am I doing in order to find the x itself, I have to make sure that x minus 3 is not going to be equal to 0. At what point the thing happens? At a point that x equals to 0 itself. So I would say that x could be any number, based on my finding, obviously not any number. I have to follow some steps in order to find x itself, except the 3 itself. Even if I find x as 3, I cannot use it because again, x is equals to 3 is going to do me something. It would be 2 divided by 0 is equals to 5. Obviously, we know that 2 divided by 0 is undefined. So obviously, it's not going to be equals to 5. So this is something that we have to consider when we're solving questions or fraction question-wise, when our variable is going to be what? On the denominator itself. Please be careful. We will talk about it, at how we can solve it, but this is a rule, or this is the fact that you have to know. So let's move to another position. Let's have our very, very first example at this point. So basic multi-step. Again, we completely know about that. We had it in the last part, we had it in the last module. So the only thing that you have to do in order to make sure all of those variables are on one side and all of the numbers on the other side, and bam, you can completely find the answer. So let's start from this point. I do have 3 times x minus 2 subtracted by 4 is equals to x plus 5. So the very first thing that I have to do, multiply 3x by x by a negative 2. Again, why I'm trying to do that? Because I want to get rid of fraction itself. So what you got? 3x minus 6, and after that I do have the minus 4 itself. It would be 3x minus 10. Cool. So I have to put at this point that 3x minus 10 is equals to 2x plus 5. So I have to rearrange it. How I have to rearrange it? I have to make sure that all of the x's are on one side and all of the other some kind of numbers on another side. So what is extra over here? Probably I can get rid of some kind of positive 2x itself. Again, reverse operation, reverse operation. So what do we have? I do have 3x minus 2x, which is going to be x itself. And after that, I do have, let me just write it down like this. 3x minus 2x minus 10 is equals 2x plus 5 minus 2x. This guy is going to cancel out this one. So I do have this guy, x subtracted by 10 is equals to 5 itself. Is that so? So another thing that I have to do, because I told you I have to move all of the numbers to another side, right? I have to move all of the numbers to this side, and I have to keep my x at this side. So I have to add it with 10, add both sides with 10. So you have x is equals to 15. If you want to check that your answer is right or not, you have to put the 15 on the left side. If you do that, you get this number, and 15 on the right side. So you know that your left side and right side are the same. So you're good, and you don't have any problem with that.